All right, guys, so what we're going to be looking at here is the first of many different units where we look at what is expected of you on the AP test when a particular type of problem shows up. In this video, we're going to be talking about particle motion problems and what those deal with and how we deal with those problems while we're taking the AP exam. So just be aware that's what we're looking at here as we go through these, okay? So in general, when we look at a particle motion problem, on the AP test, just as, again, as a kind of a lead in here, you'll always be given some sort of situation that is happening in the problem to start with. They won't even start with the problem like solve this or solve this. For the most part, especially on the free response, what you're going to see is you're going to see a problem that deals with a particular scenario. And one of those scenarios is dealing with something that is known as particle motion. What I have noticed in general is particle motion is very unique to the AP exam. Not that it's more difficult, but it is something that I've never really seen outside of the AP exam, or at least not very much. So what happens in these particle motion problems is two things. First of all, we're dealing with a little teeny tiny dot, if you will, moving backwards and forwards across something. And what happens is you're usually given a velocity function in these problems. Not always, but I would say probably 95% of the time you are given a velocity function when you look at these problems. The second thing that is true is the particle that you're talking about is moving backwards and forwards in one dimension. So it's either moving left and right, or it's moving up and down, or it can be moving forwards and backwards. But it's always in one dimension, usually to the right or up or forward is considered to be a positive direction, and the other ones are considered to be a negative direction. One thing that you'll also be given in a particle motion problem that you can pretty much just ignore every single time is the problem will tell you what line the particle is moving backwards and forwards on. Like it might say x equals 1, okay? All you think about is if I'm looking at a line, x equals 1, it just means the particle is moving up and down on that line. It has nothing to do with the problem. They're just putting that information in there to kind of confuse you a little bit, like why did they say this? It's not that it's unimportant, it's just something that you will never use. So whatever line the thing is moving on, don't worry about it, because it will not have a bearing on how you do the actual problem, okay? So again, most of the time we're talking about this thing moving backwards and forwards, up and down. Honestly, once you recognize what it is that you're looking at a particle motion problem, the first thing that you really should look for is what function they give you. Like I said earlier, most of the time they're going to give you a velocity function. But that is not always the case, and it's really, really important that you understand what it is you are looking at as far as the function that you actually have. If they give you a velocity function, what they'll almost always give you as well is some sort of initial position of the particle. It'll say the particle is at x equals 3 when time equals 2 or something like that. That part of the problem is important because you'll have to use that piece of information as you work through the problem. So again, just be aware of that. So here are, and none of this, I will say, and I know this is true about all the review stuff, none of this stuff is new, okay? So I'll go through this kind of quickly, but here are all the topics that we have previously discussed. We've talked about total distance traveled. We'll go through all of these, actually. We need to talk about each of these to make sure that we understand what is going on. So total distance traveled, displacement, and position. Let's look at that topic first. When I'm asked to find one of these three things, whether it's total distance traveled, displacement, or position, again, what you will have probably is a velocity function as well as what line the particle is moving backwards and forwards on and an initial position. If you're given those three things, then total distance traveled is always, remember, that's how far the object has traveled during its travels, if you will. The way that we always find it is we do the integral from a to b, where a is the start time and b is the end time, of the absolute value of the velocity. The displacement is just how far you are from where you started, and negative and positive numbers when you have a displacement just means if you get a negative number, you're further to like the left than you were when you started. If it's positive, then you're further to the right. The way that we find displacement is we do the integral from a to b of the velocity function. Notice that there is no, in this case, there is no absolute value around the velocity. That's the difference between total distance traveled and displacement. When it comes to finding position, Position, you take the displacement that we talked about here, like this displacement, and then what you do is you just do the initial position plus that displacement. That will tell you where you are. Displacement tells you how far you've gone over a specific time. And then the position, that's just your orientation as to where you started. So again, hopefully that kind of makes sense as far as what the difference between those three things are. Okay? If you want to know when you'll be asked to do those things, really, they're very self-explanatory. Okay? It'll be like, tell me what the position is, or tell me what the displacement is, or tell me what the total distance traveled is. If you see those words, then chances are you're good to go, and you can be like, oh, okay, I get that. That's not that big of a deal. Okay? The one thing you do have to make sure that you've got is the velocity of the particle. If you don't have that, then it's actually almost impossible to find those things, especially using calculus. So that was total distance traveled. Now we're going to talk about reading particle motion graphs. When you're looking at a particle motion graph, sometimes instead of giving you a function for the velocity, they'll give you a graph of the velocity. Okay? So if you were given a graph of the velocity and you were asked to find the acceleration, what you would have to remember is, although there is no function that you can look at, the acceleration is the derivative of the velocity. The derivative tells us the slope of the tangent line. So if I'm looking to find the slope of the graph as it passes through a given time on the graph, and that's important as well, what it's really asking you to find is the slope when time equals whatever it is that you're looking at. Okay? So here's an example. Let's say this is a velocity graph. Whoops. And I'm like, okay, if this graph were v of t, what would a of 4 be? Now what that's asking is, what is the derivative at time equals 4? So what I would do is I'd say, okay, this point right here, I can see this point is 3, 3. I can see that this point down here is 6, 0. So I would just find, or 0, 6, no, that's sorry, 6, 0. So I'd find the slope between those 2 points. So it'd be like 0 minus 3 over 6 minus 3. So I'd get negative 3 over positive 3, which is equal to negative 1. That would be the slope. That means that would be the acceleration at that particular time. Okay, and again, hopefully that kind of makes sense is what acceleration would be. Most of the rest of the time, you can find acceleration no problem. Now, another thing that we would need to talk about is whether or not a particle is speeding up or slowing down. And honestly, there are really 4 different things that can happen that tell you whether a particle is speeding up or slowing down at a given time. If both the velocity and the acceleration are positive, then what's happening is we are speeding up. If you remember back to the thing that we did in class where I tied the exercise bands on, that means I'm walking in the same direction that the force is pulling me in. If both the velocity and the acceleration are negative, that also means that I am speeding up. And that one tends to be the one that most people struggle with because they're like, oh, how do I tell if I'm speeding up there? You would just say, yes, they're working together. If they don't match up, then we are slowing down. So if the velocity is positive, the acceleration is negative, then we're slowing down. And if the velocity is negative and the acceleration is positive, they're not working together, so that's slowing down as well. So that's how you can tell. In other words, I need to know what the velocity is at a specific time, and I need to know what the acceleration is at a given time, and then just compare the two. Now, it doesn't matter how big or small the numbers are. I just care whether or not they're positive or negative in each of those instances. Okay? Now, again, one thing that is true is when we're talking about motion, I said this earlier, if a particle is moving to the right or up, what that really means is the velocity is positive. Anytime we're moving to the right or up, we consider that to be a positive direction, and the velocity tells us whether we're headed in a positive or negative direction, so the velocity would be positive there. If the particle is moving to the left or down, we would say the velocity is negative in that particular scenario. Okay, and then one thing not to forget, if an object is speeding up, and I said this earlier, but it's really important, if you're looking to see if an object is speeding up or slowing down, you have to look at both the velocity and the acceleration. Velocity by itself will not tell you that. Acceleration by itself will also not tell you that. You have to look at both of them and then compare the two. Okay? Lastly, we need to talk about speed, velocity, and acceleration. Now, these are more if you have the position function, which will happen sometimes. If you have the position function, then speed is given by the absolute value of the derivative of the position function, or the absolute value of the velocity function. Speed is just how fast you are going without direction. So it's a positive number no matter what. That's why we put absolute values around them. Acceleration is how fast the velocity is changing. If we're given the position function, the way that we find the acceleration is by finding the second derivative of position, which is the first derivative of velocity. And again, we've talked about those things quite a bit. This is a good reminder on what those different things mean. Now that we have that down, let's take a look at a problem from a previous AP exam. Now, this is from a little while ago, but I think it gives us a good feeling as to what is happening. This is from 2005. Okay, so here's the question. A particle moves along the x-axis so that its velocity v for time between 0 and 5 is given by, and we've got this velocity function right here, and the particle is at position x equals 8 at time equals 0. Now, honestly, the very first thing that you should always ask yourself on every problem on the AP test is, what did I just read? What did they just give me? And I know it takes longer to read a problem, but you've got to read them in order to understand everything else that's going to be asked of you. Okay? So let's take a look. In this problem, we have, I've got a velocity function. It's important to understand I have the velocity. They also give us a time interval. That's kind of important. It's not super important because usually they won't ask questions outside of that interval. But they also give us a position at a specific time. So that's like our initial position. So here I have my initial position, I have a velocity, and I have a time interval that we're talking about. Okay? So now I know what I have. And again, that's very important to answering everything else in the question. So now we say, okay, letter A says find the acceleration of the particle at time equals 4. Well, what we have to realize is, how is acceleration related to what we're given in the problem? To find the acceleration, all we're being asked to do is, where did I go? All I'm being asked to do is find the derivative of that right there. Now, luckily for us, if I had my calculator, I can have my calculator do this. If you remember, the way that we do that is you just press the math button and then number 8. And this appears on your screen. Once you do that, you just type in the function you want to take the derivative of. You don't have to take the derivative. Then at the very end, you press 4, and it will tell you what the answer is. I don't have it right in front of me, honestly, but that's how you would find that answer. All you would have to write on a question like this one is you would just say, okay, A of 4, you'd say A of 4 is equal to whatever that number was that we got when we typed that into the calculator. So that would be your answer to letter A. You'd be all done. Letter B says, okay, what I want to know, during which time intervals does the particle travel to the left? Well, in order to answer this question, what we have to look at is we have to say, okay, what's going to happen if a particle changes direction? And one of 3 things has to be true. You could say, is it the position, the velocity, or the acceleration must equal 0? Well, hopefully in this case you realize that in order to change direction, the velocity must equal 0. The other ones, the position equals 0, you can be traveling in either direction. The acceleration equaling 0, that just means I'm not speeding up or slowing down at that time. But if my velocity equals 0, that means I have changed direction. Now you might be asking, why do we want to do that? Well, since we have our calculator, I would just graph my velocity. Now, one thing I want to call your attention to on this problem is the problem said that I was looking from time equals 0 to time equals 5. So I pressed the window, or the second window button, and just the window button, and I changed my x values from 0 to 5 so I could look at what was happening. Once I did that, I just wanted to find out where it's below the x-axis. So I press second trace, and then I look for my zeros to find out where it crosses the x-axis both of those times. And we can find out exactly where that happens. Okay, there's those 2 places. In this case, is time equals 1 and time equals 2. So what we would say is that's our interval from 1 to 2. So we would say, okay, we know that that is where the velocity is negative. So what you would say for your answer is from time equals 1 to 2, because that's where the velocity is negative. And you can even use just the negative symbol. You don't even have to write the word, okay? And that would give you full credit on that problem. Question number, letter C, wants us to find the position of the particle. Now remember, position is defined, we talked about this earlier, as initial position plus the integral from a to b of the velocity function. In this case, that is 8, that's our initial position like we identified earlier, plus the integral from 0 to 2, because at time equals 0, that's when the particle was at 8, and I want to know where it is at time equals 2. So I just do the integral from 0 to 2 of that function, and it gives me 8.369. If you wrote this right here, that amount of work is sufficient for a problem like this one. On letter D, and we didn't talk about this a ton earlier, but letter D says find the average speed of the particle. Now, way back in the day when we were talking about this in class, we did define what average speed is. Average speed is displacement divided by total time elapsed. So if I'm going from 0 to 2, that's my time elapsed. So 2 seconds or 2, whatever it is, okay? What I need to find now is my displacement. Well, we talked about that earlier. That's just the integral from 0 to 2 of my velocity function. If I divide that by 2, then I get my answer, and that will tell me what the average speed is. Again, that one's a little bit tricky because we haven't talked about that before, and you'll notice on the AP test, they do that from time to time. They'll give you 3 questions, you're like, oh, I got it, and then the 4th one, you're like, oh, I don't remember that one quite as well. But this is very typical of what you would see on a particle motion problem. So hopefully that makes sense. And if you have any questions about this or how these problems work, please let me know.